Recording. And here we go again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so all this week, we're going to be reviewing for the final exam, which is next week. I believe it's on Monday. Anyway, I'm just going to go through section by section and highlight some things. If you have questions, if you want more examples, please speak up, let me know, and we will do that. All righty. So without further ado, I'm going to go ahead and go to section 3.7 and take a look at the material that's there. And so to do that, I'm going to switch screens. So give me a minute here. Let's see here. Get this going, hopefully correctly. Okay. All right, so now you should be seeing the graphing screen. Is that correct? Can somebody verify that, please?
Yep.
Thank you very much. Okay. So section 3.7 was graphing linear inequalities. So I'm going to do just a couple examples of that. And then, as I say, if you want more, let me know. So let's see, this is section 3.7. Okay, well, let's take this one. We have 5x plus 4y greater than or equal to 20. Okay, so the idea is to graph the inequality and then shade the correct side, of the line, determine whether it's solid or dotted, etc. Okay, first of all, we're going to consider the equation 5x plus 4y equals 12. And then we're going to find two ordered pairs that are solutions to that equation. We don't always have to do this, but using the x and y intercepts is often a good set of choices. So if y is 0, we get 5x plus 4 times 0 equals 20. 5x equals 20. Divide by 5, x equals 4. If we let x equal 0, we get 5 times 0 plus 4y equals 20. 4y equals 20. Divide both sides by 4 and y equals 5. So we now have the points 4, 0 and 0, 5. So going over to our graph, let's see here, let's label this. And we have 4, 0 and 0, 5. And let's see here. Go ahead and use a straight line here. Where did it go? Here it is. Okay. So we'd have what? This line here. Now, I drew a solid line. Let's go back and let's talk about that. The original inequality was greater than or equal to 0. So the line would be solid. Recall, if it did not include the equal, the line would be dashed. Okay, so now I know where this line is. And in fact, let's extend it on the other direction as well. anyway. So now I need to determine which side of that line is included in the solution. To do that, I pick a test point. Okay. And 0, 0 is a good test point if it's not on the line. You never want to pick a test point that's actually on the line. 0, 0 is not on the line. So we'll try 0, 0. We're going to put that into the original inequality statement. So 5 times 0 plus 4 times 0 greater than or equal to 20. 0 greater than or equal to 20, that's false. So the test point's no good. So that means that instead we're going to be on above the line. Okay. So the solution would be the solid line and shaded above the line. All right. Now, recall in WebAssign to graph this, what you do is over on the left side of the page of the graph, there's a bunch of squares. You find the one that has, it looks like this, it's got a line on it, and you click on it until it turns blue. You want the solid line, not the ray and not the line segment, okay? But you want the solid line. Then you click on the 2 points, okay? That's going to form the line. If it's going to be a dotted line, you have to go over to the right side of the page and click on it to make it dotted. And then there's a place to shade it. Does any of you have any questions about the WebAssign technique of doing this? Okay, all right. And let's go on to another example. This is still in 3.7. And let's see here. Yeah, this will work. Okay. Y is less than x over 3 minus 1. Okay. So we're going to consider the equation y equals x over 3 minus 1. Okay. Again, I'm going to find 2 ordered pairs. And again, I'm going to use the x and y intercepts and see what happens. If y is 0, I get 0 equals x over 3 minus 1. I'll add 1 to both sides. 1 equals x over 3. Multiply both sides by 3, and x equals 3. If x equals 0, I get y equals 0 over 3 minus 1. So y equals negative 1. So I've got the points 3, 0, and 0, negative 1. Okay. And now, this does not include equals. So it's not a solid line, it's a dotted line. Let's see if I can do that. Okay. And so there's our dotted line. And then I need to determine, is it above or below? Again, 0, 0 is a good test point. So test point 0, 0, we'll plug that in here. 0 less than 0 over 3 minus 1, 0 less than negative 1, that's false. So it's not here, it's over here. But it has a dotted line. Any questions about that example? All right, then let's move on to section 4.5, which was solving systems of linear inequalities. And let's see here. So now we end up having 2 linear inequalities on the same graph, and we look to see where they overlap. So let's see, let's take this one. We have 3x plus y less than or equal to 1. Okay. And we'll go through and do the same thing we just did with this particular inequality. So I'm going to look at the related equation. I'm going to find a couple of ordered pairs that are solutions. Again, I'm going to use the X and Y intercepts. The only time that wouldn't work is if the actual graph goes through the origin, and then I'd have to find an additional different point besides the intercepts. Okay, if Y is 0, 3x equals 1, divide by 3, x equals 1/3. If x is 0, we get 3 times 0 plus y equals 1, y equals 1. So I've got 1/3 comma 0 and 0, 1. So 1/3 comma 0 is right about there. And 0, 1 is right about there. That's going to be kind of tricky, isn't it? Let's see. I'm going to graph that. It's not going to be super accurate because of what I'm using here, a ruler. Oh, it's going to be a solid line, isn't it? Okay. And it doesn't go through the origin. It looks like it on my graph, but it doesn't. So my test point is going to be 0, 0. So I'm going to plug in there 3 times 0 plus 0 less than or equal to 1, 0 less than or equal to 1. That's true. So it's going to look like this. Okay. Now, before we go on to the second part of the graph, recall that in WebAssign, when you try and graph like a fraction, so like this point right here, it's going to be difficult to do. So what you're going to want to do is in WebAssign, you go over on the right side and click on where the line is, and the ordered pairs drop down, and you can put in the specific ordered pairs. Okay. Recall that you don't want to use mixed numbers, use fractions, or if necessary, improper fractions. I suppose you could use decimals, but 1/3 is not 0.3, it's 0.3 repeating. So you want to try and avoid that. Anyway, okay. So I've got the first inequality. Now let's go back and do the second inequality. And let's see, where did I get that one? Here we go. 4x minus y greater than or equal to -8. So I look at the related equation, 4x minus y equals -8. Again, I'll use the x and y intercepts. When y is 0, 4x minus 0 equals -8. 4x equals -8. Divide by 4, divide by 4, x equals -2. If x is 0, 4 times 0 minus y equals -8. Negative y equals -8. Divide both sides by -1. Y equals 8. The points -2, 0 and 0, 8 are here. This is also a solid line. Okay. And I'll use 0, 0 as a test point, putting 0, 0 in there. 4 times 0 minus 0 greater than or equal to -8. 0 is greater than or equal to -8. That's true. True. So this point, this is going to look like this. Now, again, recall in WebAssign, when you start clicking on shading areas, when you click on, for instance, for the black, we would have this one and this one. For the red, we would have this one and this one. So what you need to do is ultimately just click on the one where they overlap, which would be this one. Okay. Any questions on 4.5? Do you need another example? Are we good to go on? If you don't say anything, I'll assume we're good to go on. All right. So what I'm going to do now is I'm going to go back to my regular whiteboard screen. That's just easier to use. So give me a second here to switch things over. Yeah. Okay. All right, we should be back to the whiteboard screen. Now, that takes us to section 14.1. So let me get there, 14.1. whoops, 14.1, where we dealt with factorials. Recall that, for instance, 4 factorial is 4 times 3 times 2 times 1. And we could take, let's say we have 4 factorial over 3 factorial. We could write 4 factorial as 4 times 3 factorial. And then we could cross out the 3 factorials and just get the number 4. So let's take a look here at a couple more examples. Let's say I've got 49 factorial over 46 factorial. Well, that's 49 times 48 times 47 times 46 factorial over 46 factorial. I could now come in and reduce out the 46 factorials. So I've got 49 times 48 times 47. Then I'll take that to the calculator, 49 times 48 times 47, and I get 110,544, 110,544. Any questions on that example? Okay, let's take a look at another one. Here we have, let's see, 6 factorial times 7 factorial all over 8 minus 3 factorial times 7 minus 4 factorial. So the first thing I'm going to do is simplify inside the parentheses. 8 minus 3 is 5 factorial. 7 minus 4 is 3 factorial. So now I've got this situation. What I could do, and there's a couple of different ways I can do this, but I'm just going to choose a particular one. I'm going to put these two together and these two together. So I'm going to take the 6 factorial and write it as 6 times 5 factorial over the 5 factorial. I'm going to take the 7 factorial and write it as 7 times 6 times 5 times 4 times 3 factorial and put that over 3 factorial. I'm using X's for multiplication symbols. I suppose I could go back and use dots instead. Just don't confuse it with thinking it's a variable, because it's not an X variable, but we'll just do it this way. Okay, so now the 5 factorials reduce out and the 3 factorials reduce out. So on top, I've got 6 times 7 times 6 times 5 times 4 all over 1 in the new denominator. So let's see, 6 times 7 times 6 times 5 times 4 is 10,920. Okay, let's see here. Hang on. Okay, I'm going to here and pause. All right, I found my mistake. On my calculator, I wrote 6 times 7 times 65 times 4. Okay, 6 times 7 times 6 times 5 times 4 equals, there we go, 5,040. Okay, sorry about that. The fingers not knoweth what the brain doeth, or something. Okay, are we okay with section 14.1 factorials? Need any more examples there? If so, speak now or forever hold your peace. Okay, we're going to go on to section 14.2, where we looked at arithmetic sequences. Okay. And they gave us some specific formulas to use on specific problems. But then if they didn't give you one on a specific problem, we were to use the general arithmetic formula, which is this, arithmetic sequence formula. A sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub 1 is the first term of the sequence, d is the common difference. Okay, so let's look at some examples of this. This says, write the first 5 terms of an arithmetic sequence with the given properties and find the specific term. Okay, let's see. It says the first term is -5. The common difference is -3, and we are to find the 15th term. Okay, so a sub 1 is -5, d is -3, and we are to find a sub 15. Okay, so using this formula, a sub n, that would be a sub 15. Wait a second. The direction said find the first 5 terms and then go on with that. So we need to do that. So let's do that first. A sub 2, a sub 3, a sub 4, a sub 5, and then we'll find a sub 15. When all else fails, read and follow the directions. If the common difference is -3, that means that we add -3 to a sub 1 to get a sub 2, right? So this is going to be, let's see here. A sub 1 is -5 plus -3 would be -8 plus -3 would be -11 plus -3 would be -14 plus -3 would be -17. Well, I don't want to do that 10 more times. I suppose you could out of desperation, but now we're going to go back to find the 15th term by doing this. Using this formula, a sub 15 equals a sub 1, which is -5, plus n, which is 15, minus 1 times d, which is -3. So then this is equal to -5 plus 14 times -3, which is -5 plus, let's see here, what's 14 times -3? That's -42, and that becomes -47. Okay. Any questions about this particular problem? Okay, let's see here. Another example. The first 3 terms of an arithmetic sequence are shown below. A sub 1 is -5. A sub 2 is -1. And a sub 3 is 3. We are to find a sub 28. All right. How do you find D, the common difference in an arithmetic sequence? You take any term in the sequence minus the previous term. So A2 minus A1 would be -1 minus -5, which would be -1 plus 5, which would be 4. Okay. And let's see here. So D is 4. Our formula, a sub n equals a sub 1 plus the quantity n minus 1 times d. Now we've got all the information we had in the previous problem at this point. So a sub 28 equals a sub 1 plus 28 minus 1 times d, which is -5 plus 27 times 4, which is -5 plus, let's see, 27 times 4 is 108. Adding those together, we get 103. And let's see, they just, hang on here. Okay, let's see, 103. All right, questions about that one? Okay, let's take a look at Let's see. This says, write the first 5 terms of an arithmetic sequence with the following properties. The first term is 5, so a sub 1 is 5. The fifth term is 29, and they want us to do this. Okay, first term is 5, fifth term is 29, and they want us to write the first 5 terms. Okay, so using the formula, a sub n equals a sub 1 plus the quantity n minus 1 times d. Okay, we know that a sub 5 equals 29. We also know that a sub 5 equals a sub 1, which is 5, plus 5 minus 1 times d. So a sub 5 equals 5 plus 4d. Well, since a sub 5 equals 29 and a sub 5 equals 5 plus 4d, 29 equals 5 plus 4d. Subtracting 5 from each side, 24 equals 4d, divide by 4, d equals 6. So 5 plus 6 is 11, plus 6 is 17, plus 6 is 23, plus 6 is 29. And there you have, let's see, it said, write the first 5 terms. So there we have it. Any questions there? Okay. Now we're going to insert some arithmetic means. It says, insert the given number of arithmetic means between the numbers. Okay. It says 3 arithmetic means between 20 and 80. So a sub 1 equals 20. Then we're to find 3 arithmetic means, which means the last term that was given, which is 80, is a sub 5. So we're told to put 3 arithmetic means between 20 and 80. 20 is a sub 1, 80 is a sub 5, 3 in the middle. Okay. So again, we're going to use this formula. We know that a sub 5 equals 80. We also know that a sub 5 equals a sub 1 plus 5 minus 1 times d, which is 20 plus 4d. So we've got this, and let's see here. A sub 5 equals 80, and a sub 5 equals 20 plus 4d. So 80 equals 20 plus 4d. Subtract 20. 60 equals 4d. Divide by 4. d equals 15. 20 plus 15 is 35. 35 plus 15 is 50. 50 plus 15 is 65. 65 plus 15 is 80. So the 3 arithmetic means are right there. Any questions there? Okay, let's go on to section 14.3. And this was geometric sequences. And here we're going to use the formula. If I can find it here. What is it? Oh yeah. A sub n equals a sub 1 times r to the n minus 1 power. Now r, instead of being the common difference like the arithmetic sequences, r is called the common ratio. So here again, let's see. Write the first 5 terms of each geometric sequence with the given properties and then find the specified term. Okay. So let's see. We're told that the first term is -2. The common ratio is 2, and we're to find the 8th term. Well, first of all, it said to write the first 5 terms. And then we're supposed to find the 8th term. So a sub 1, -2 times r. -2 times 2 is -4. Negative 4 times 2 is negative 8, times 2 is negative 16, times 2 is negative 32. And again, I could find a sub 6, a sub 7, a sub 8, but we need to use the formula to find that last term. So let's see. A sub 8 equals a sub 1, negative 2, times 2 to the n minus 1 power. So that's negative 2 times 2 to the 7th power, which is negative 2 times, let's see here, 2 to the 7th power is 128, and that times negative 2 is negative 256. So there we have the first 5 terms of the geometric sequence and the 8th term. Okay, let's see here. This says the first, find the specified term of the geometric sequence with the following properties. The first 3 terms are 50, 100, and 200. Find the 10th term. All right. Geometric, so a sub n equals a sub 1 times r to the n minus 1 power, okay? We need r, okay? How do you find the common ratio with a geometric sequence? You take a term in the sequence divided by the previous term. So a sub 3 divided by a sub 2, 200 divided by 100 is 2, so r equals 2, okay? So a sub 10 is a sub 1 times 2 to the 10 minus 1 power, which is 50 times 2 to the 9th power, which is 50 times, let's see, 2 to the 9th power, 512. 512 times 50 is 25,600. So find the specified term. There it is. Okay. The next one, it says, write the first 5 terms of the geometric sequence with the following properties. The first term, so here, let's go. A sub 1 is 2. It says r is greater than 0, so r is positive. And the third term is 18, right? The first 5 terms. So we're supposed to find a sub 2, a sub 4, and a sub 5. Okay. Now, we're going to use the formula. A sub n equals a sub 1 times r to the n minus 1 power. We know that a sub 3 is 18 because it's given. We also know that a sub 3 equals a sub 1, which is 2, times r, we don't know what r is yet, to the n minus 1 or 3 minus 1 power, okay? So a sub 3 is 2r squared, and a sub 3 is also 18. Therefore, 18 equals 2r squared. Divide both sides by 2, r squared equals 9. R squared equals 9, take the square root of it. You get r equals negative 3, r equals 3. However, r is positive, so we throw out the negative. 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162. And there we have it. Find the first 5 terms. Any questions there? Okay. This says, find the geometric means to be inserted in each geometric sequence. It says, insert 4 geometric means between 3 and 96. So a sub 1 is 3, and then we've got these 4 geometric means we're going to insert. So a sub 6 is 96. Okay. We're going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. And let's see, what do we know? We know that a sub 6 is 96. We also know that a sub 6 is a sub 1, 3 times r to the n minus 1, or 6 minus 1 power. A sub 6 is 3 r to the 5th, but a sub 6 is also 96. So 96 equals 3 r to the 5th. Divide both sides by 3. And we get what? 32 equals r to the 5th. I'm going to rewrite it like this. I'm going to take the 5th root. Now, back when we first looked at this, we hadn't explored radicals much, but now that we have, taking the 5th root of 32, we get what? Let's see, the 5th root of 32, 5, that 32, and I get 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. And we have that. All right, so that concludes the review on the first test, unless there's any questions, anything you want to go back and look at. Otherwise, I'm going to go ahead and start chapter 5. So I will do that now, because we've got 6 tests worth of material to cover in 5 days. So we're going to go ahead and start with chapter 5. And let's see, we started at 5.4. So section 5.4. Yeah. Which was polynomials. And we had monomials, binomials, trinomials, and just polynomials. Monomials, 1 term. Binomials, 2 terms. Trinomials, 3 terms. Polynomials, many terms. And we find that we can group all of the monomials, binomials, trinomials, etc., and call them polynomials. Technically, I don't think a monomial should be called a polynomial, but every book I've ever seen on math does that. So we'll just call them all polynomials. Okay. Now, the degree, let's talk about the degree of a term. So let's say I've got 4x cubed. This would be a 3rd degree monomial. Okay, it's a single term, but the exponent on the variable is a 3. So it's a 3rd degree monomial. Okay, let's say I had 5x squared y to the 7th plus 2x cubed. Okay. The degree of the first term is 9th. The degree of the second term is 3rd. So the first term is a 9th degree term. We add all the exponents on all the variables. The second term is a 3rd degree term, but the degree of the entire binomial in this case is equal to the degree of the highest powered term. So this would be a 9th degree binomial. Binomial because it's 2 terms, 9th degree because the highest powered term is 9th degree, adding the exponents of the 2 and the 7. Any questions about that? Okay, let's see here. We had evaluate expressions. Let's say we've got something like this. A cubed minus 2ab plus b cubed, and a is -2 and b is 3. So to evaluate the expression, we substitute the numbers in the place of the variables. So we get -2 the quantity cubed minus 2 times negative, oops, this is what happens when I'm hurrying, not a good thing, times negative 2 times 3 plus 3 cubed. Negative 2, the quantity cubed is negative 8. Minus 2 times negative 2 would be a plus 4 times 3 is plus 12 plus 3 cubed is 27. And negative 8 plus 12 is 4. 4 plus 27 is 31. Let's see here. Any questions about that? Anything there? Okay, we'll go on to section 5.5. We'll get as far as we can and then we'll pick up from there tomorrow at the end of chapter 5. So this is section 5.5, adding and subtracting polynomials. So let's say we're adding, about this, 2x squared plus xy plus 3y squared plus the quantity 5x squared minus y squared. If there is a set of parentheses with nothing in front of it, we can drop the set of parentheses. If there's a plus sign in front of it, we can drop the parentheses. So this becomes 2x squared plus xy plus 3y squared plus 5x squared minus y squared. Combining like terms, these are like terms and those are like terms. I've got 7x squared plus xy plus 2y squared. Okay. Let's see here. Let's do a subtraction. So 2b squared plus 3b minus 5 minus the quantity 2b squared minus 4b minus 9. Now, again, nothing in front of a set of parentheses. We can drop the parentheses. A subtraction sign in front. We distribute the subtraction sign. It's like distributing a -1 to each term inside, which changes the sign of each term inside. So -1 times 2b squared minus 2b squared. -1 times minus 4b is a plus 4b. And -1 times a minus 9 is a plus 9. Now combining like terms, 2b squared minus 2b squared, those cancel. 3b plus 4b is 7b, minus 5 plus 9 is plus 4. So we get 7b plus 4. Okay. Let's see here. Any questions about that? All right. This takes us to section 5.6, which is multiplying. You know what? I'm looking at the time. We'll quit. We'll pick up here tomorrow. Okay. So we'll pick up at section 5.6 because I don't want to try and rush through this in 5 minutes. So that's all for today. Like I say, tomorrow we'll pick up the section 5.6. We'll finish chapter 5, and then we'll go on and look at chapter 8 and on into the rest of the week, chapter 9, 10, and 11. So I will be back this afternoon at 1:15 with an office hour. Otherwise, I'll be back tomorrow morning to pick it up from section 5.6. So let's stop the recording.